Chapter 7 is on glaciers and desert environments, but we're predominantly just going to focus on glaciers. There are going to be 3 or 4 slides at the very end of this PowerPoint talking about deserts, but we're going to focus on glaciers, and we're not even going to cover all of the material on glaciers, since we're covering 2 chapters in one. A glacier is just a really thick mass of ice. So if you watch the Game of Thrones series, they had the Wall, where they had miles thick sheets of ice. And glaciers can be like that. Not all glaciers are really huge, thick sheets of ice, but a lot of them are. But glaciers take a really long time to form. We're going to see that it takes hundreds or thousands of years for our snow to compact and freeze into a solid glacier. So glaciers form by accumulation of snow. If you give it thousands of years and you have 1,000 years worth of snow that is accumulated or built on top of each other, it's going to have a lot of a weight to it. And that weight is going to begin to compact the snow into lower layers. And as it's compacted, that snow is going to recrystallize. It's going to go from loose snowflakes or loose individual crystals. And as it's being compacted, it's going to recrystallize into larger grains. So instead of having just a loose pile of snow, now it's all consolidated into one gigantic chunk of ice. But just like we see with a stream, glaciers flow. But glaciers flow very, very slowly because of gravity. So as our glaciers are accumulating, they're gaining more mass. And if they weigh more, gravity is going to have a bigger pull on them. So we see that glaciers typically move downwards in elevation. It might move towards the edge of an ice sheet, like we see in this image, or it might move downhill if that glacier is on top of a mountain. But while our glaciers are very slowly moving, just like a river, they're going to be transporting and depositing sediment as they very slowly move. When we look at our landscapes or the surface of our continents today, a lot of them were changed during our last ice age by glaciers. So the last ice age happened about 20,000 years ago, and oddly enough, it's very similar to a lot of the conditions we actually see in the movie Ice Age. But glaciers are going to be important in both our water, our hydrologic cycle, as well as our rock cycle. And this is because as water is trapped as ice inside of these glaciers, it can't move around the rest of the hydrologic cycle. So that water can be trapped inside of the glacier for thousands of years until it eventually melts. Then it can go through things like evaporation or precipitation again. But glaciers are not just important for our water cycle. They're also really important for our rock cycle as well, because they are really, really good at weathering material, specifically mechanically weathering it. And that's because as this ice very slowly moves, it might be thousands of pounds pushing down on the surface or the rocks beneath it. So as it slowly moves across these rocks, it's going to mechanically weather it, or break it down into smaller sized pieces. When we're looking at all of the different glaciers on our planet, we'll notice that there are different types. And these types are going to differ on where they are, as well as how the ice accumulates. So our first type of glacier that we're going to discuss in this chapter is called a valley, or an alpine glacier. These are the ones that are found in really high mountainous areas. So if you've ever seen a mountain, or even a picture of a mountain where it looks like it has snow and ice at the very top, this is a valley or an alpine glacier. For the most part, these are relatively small glaciers, and they're going to be confined into the valleys, the very low-lying areas of our mountain. And remember, glaciers flow just like a river, but they move incredibly slowly. So these valley glaciers move at a few centimeters per day, maybe an inch per day maximum. And they're just going to flow down the valley because of gravity. But one of the things about alpine glaciers is that usually it's a really narrow width. It might be a few hundred feet across, but they're very, very long. It can go from the very top of a mountain all the way to the base, which could be miles in length. So they're very narrow, but they're very long formations of ice in these really high mountainous regions. But a totally different type of glacier is called an ice sheet. And ice sheets are going to be really different from our valley glaciers. With these ice sheets, it's going to be an entire sheet of ice that covers solid rock. The two largest ice sheets on our planet are found in Greenland and Antarctica. For these, whether Greenland the island or Antarctica the continent, the entire rock is covered in ice. It's a huge scale glacier, so everything underneath the ice is going to be completely obscured. But just like we saw with our valley glaciers, these are also going to flow downwards due to gravity. But because it's a flat sheet, it can't really flow down like it would in a mountainous area. Instead, it's going to flow outwards in all directions from the very center. So the very center of our ice sheet is going to be the thickest, and as we get around to the edges, it'll be thinner. So we always see that our ice sheets are flowing from the center outwards in all directions. Today, the two largest ice sheets are in Greenland and Antarctica, but it hasn't always been that way. During the last glacial maximum, or the last time we had a whole lot of glaciers on our Earth, around 20,000 years ago, there were massive ice sheets that covered most of our northern hemisphere. This map is just showing us the extent of glacial ice during this last glacial maximum, and we'll see that all of Canada, all of Greenland, and a lot of Europe is covered in a very thick ice sheet. So we're going to see a lot of features on the surface in this area that were eroded, or we see depositions of sediment as these glaciers moved through and eventually deposited all of the material they were carrying with it. But it's not just the last ice age 20,000 years ago when we had a significant amount of ice on our planet. Over the last 2.5 million years, we've had periods like the last glacial maximum where we've had significant ice coverage, and there are other periods like today where we have very little ice. So over the last 2.5 million years, we've seen that the Earth kind of swings back and forth between really cold periods, like our last glacial maximum, and really warm periods like today. There are a couple smaller features that are associated with ice sheets as well. When we have a lot of ice, especially around an ocean, we're going to get sea ice that develops. And especially the Arctic Ocean, we're going to see that there are large chunks of frozen seawater just floating along the top of our oceans. Here, because ice it expands when it freezes, it will always float on top of the water. But these pieces of sea ice are relatively small. They might be a few inches thick, up to about 10 feet. But we're going to see that the amount of ice in our oceans is going to expand and contract with the seasons. When it gets colder, we'll have more sea ice in the oceans. When it's warmer, that ice will melt and we'll have less of it. But if we look at the edges of our ice sheets, like here in this middle image, if our ice sheet, which is on top of solid rock, grows too large, and it starts hanging off the edge of solid land, it's going to turn into an ice shelf. And these ice shelves are where this glacial ice is starting to flow into our ocean. These are going to be absolutely massive, really flat shelves of ice. And we can see an actual image of one in the bottom. But all of this happens when our ice sheets get too large, and they're going to start moving outwards from the coast and start moving farther out into our ocean. But the farther out they get in the ocean, the thinner they will be. Our final two types of glaciers are fairly small, and they're not very common either. But one of them is called an ice cap, And this is going to be similar to an ice sheet, but way smaller in size. So these ice caps are still going to cover really cold areas, but now it's going to be in really high elevations, like a plateau. Like an ice sheet, they're going to cover all of the terrain that they're on top of, but again, these aren't going to be the size of an entire continent. It might just be one small, high elevation area. But our final type of glacier is called a Piedmont glacier. And these are really closely related to our valley glaciers. So these Piedmont glaciers form at the bottom or the base of our mountains. So at the bottom of our valley glacier, if it goes from a mountainous region into flat land along the base of the mountain and it spreads out in a fan-like shape, it's going to form a Piedmont glacier. It's where these valley glaciers have made it all the way to the end of a mountain range and have spilled out onto relatively flat land along the base of the mountain.